Next, we have a comparison study. Some people did some research on some green roofs, and there's Zechariah, Ashley, and Libby. And did he take that? Did you steal it? Oh, good. I knew he liked it, so I thought you did that.
Yes, I will. No, you do it, yeah. Just always. You just do it always. Yeah.
Okay, that works. Hello, everyone. My name is Zechariah Gilbert. This is Ashley Kelly and Elizabeth Turek. We're from Gannon University, and today we're going to be talking to you about a study that we did on insect diversity and quantity and small mammal diversity on our 2 green roofs at Gannon University.
So to begin, we'll just introduce what green roofs are and the benefits that they provide. So a green roof is partially or entirely covered by vegetation. It provides a lot of benefits. So for one, it improves the management of the stormwater. So in theory, less chemicals are going into the systems, but rather going into the soils and being broken down by the microbes in there. It also decreases the amount of the urban heat island effect, which in short summary, that is the idea that cities are getting hotter and warmer. So by having those green roofs, it provides more insulation, and benefits include the need for less air conditioning and more beneficial building of the buildings. It also reduces the temperature of the roof and provides insulation, It also reduces the amount of greenhouse gases that are emitted, extends the overall life of the building, and improves both the flora and fauna diversity. So, as Zach stated, we have 2 green roofs located on our campus. The first one is located on the roof of our Center for Advanced Engineering building. On the map, they're both circled. You can kind of see number 41 there. That is the first one. It is located on 8th Street, and then the other one is in our Student Learning Commons. That is our Nash Library. There's also on the roof, that's number 30 on the map there, and that is located on the corner of 6th Street and Sassafras.
All right, so just going into the locations we had. The first one, the engineering building, that one's been there a lot longer than the other location I'll show you shortly. So it's around 25 years old, just estimating the dates you can see there. It's made up of 4 plots, as you can see. Each plot was 5 feet by 12 feet. This roof, it has student access, so students can actually go in there, sit on the table and chairs, so that was kind of a factor, but the actual grass area for the green roof isn't actually walked on or invaded by anyone. So these are the traps we had on each plot. There's an aerial fly ribbon, which we put on a wooden stake. You can see in the wooden stake there. We've got a fly ribbon also anchored by rocks on the floor there, and then a Sherman live mammal trap, and these are all set up on each of the 4 plots. Next is the Nash Library, which was on the 3rd floor. This is more like a rooftop thing. The other one is on the 2nd floor, like a balcony type setting. This is the 3rd floor, so it is more of a roof. It's a lot newer than the other location we had. It's about 5 years old. And it's got the same size plots. It was a lot bigger area. We set up 4 plots of the same size. And yeah, you can go to the next slide. Go back on. Yeah. So yeah, we've got the same thing set up here with the aerial fly ribbons, the ground ones, which was anchored down, just to keep them all the same distance apart, and then also the live mammal trap. And this is our control area. It's just outside the Nash Library there. We just had 1 plot compared to the 4, just 1 control plot, same area, like 5 by 12 feet, and we've got the same setup again with the test there. But yeah, so these were the Sherman live mammal traps we had. As you can see, there was nothing like captured into them. We did bait them with some peanut butter and oatmeal as well, just to help. But yeah, we didn't find any animals in there at the time.
So these are pictures that I took of the 11 most common insects that we caught on our 2 green roofs, and it gives you a good example of the insect diversity that we had on both of our green roofs. This table shows the distribution of those 11 insects, and you can see the fungus gnats, the second one down, was our most common. We caught 145 of them, which is a lot compared to how many we caught in total, which was 190. Now, fungus gnats prefer an environment that's damp, around organic matter, and soil. And since our green roofs are actually tray green roofs, the soil stays damp for longer periods of time. So this is why we think that we caught so many fungus gnats. Our second most common was our mosquitoes, and our third most common was the green bottlefly. The other 8 insects that we captured, you can see, are far less common than those top 3. Now, if you've ever wanted to know what a fungus gnat looks like, right there's the fungus gnat, there's the mosquito, and the green bottlefly up in the right-hand corner. This is a bar graph that we constructed to help us visualize and compare and contrast the 2 green roofs with our control. And you can see with our Nash green roof, that's where we caught the majority of our fungus gnats. And there's a pretty low diversity on our Nash green roof when you're comparing it to the CAE building. So we had pretty big diversity on our CAE building, and we believe this is due to the CAE building being right around 25 to 30 years old versus the Nash green roof, which is only 4 years old. So the food chain hasn't fully worked itself in yet on the Nash building. And then right here is our control. You can see that the number and diversity is low in our control. And these are pictures of all of the blown-in plants that we have on both of our green roofs. Right now we're in the process of counting them all, just to kind of see how many we have on each of the buildings. The 3 most common blown-in plants on our CAE green roof was our coltsfoot, the upright yellow wood sorrel, and our willow herds. The number next to the name is just displaying how many were counted on that roof. And for the Nash Library, the 3 most common were our dandelions, crabgrass, and common juniper. Future plans for this research, we are going to look more closely at the blown-in plants and see how many there actually are and where succession is occurring. We're also going to continue the same study on the diversity of insects, small mammals, and birds. And we're going to implement more trapping techniques such as aerial nets for insects, and then also motion sensing cameras to help identify those small mammals and birds. And these are the people we'd like to acknowledge who helped, who led the research and also helped with the research as well. This is one of our sources. And thank you so much for listening to our presentation. If you guys have any questions, please feel free to ask.
Good job.